Now let's take a look at some trigonometric functions. But first of all, we should remember how to find reference angle, the original angle from the reference angle, because we will be using reference angle in almost every question. Okay, in the first quadrant, reference angle and the original angle is the same. And in the second quadrant, the original angle is 180 minus the reference angle. In the third quadrant, 180 plus reference angle, and the last quadrant, 360 minus the reference angle gives you the original angle. And we also need to be familiar with the signs of trigonometric function in each quadrant. In the first quadrant, they're all positive because this horizontal axis is considered to be cosine axis. The vertical axis is considered to be the sine axis. The cosine is positive, sine axis is positive, so everything is positive in the first quadrant. In the second quadrant, sine is positive, cosine axis is negative, so cosine negative, sine positive, tangent should be also negative. In the third quadrant, since sine and cosine both axes are negative, tangent is positive. In the final quadrant, sine negative, cosine positive, tangent is negative. And if you remember, there's also a hack way of memorizing the signs, like add sugar to coffee, add the first letter of add, all of them are positive. Only tangent is add sugar, S only sign is positive, 2 only tangent is positive, coffee only cosine is positive. So whatever suits you, you have to use one of the ways to remember to memorize the signs of each trigonometric functions in each quadrant. Okay, let's start solving questions. First question, study guide 4. F of x is sine x plus cosine x over the interval 0 to 2 pi. So remember what the question was. The question was finding the critical values, increasing, decreasing intervals, and local extrema. Okay, in order to find the critical value, we need to find derivative. And we check derivative being equal to and derivative being undefined. But for these kind of trigonometric functions, the derivative is never undefined, because trigonometric functions will be defined everywhere if there is no division, if there is no rational expression. So f prime of x equals derivative of sine is cosine, derivative of cosine is negative sine, equalize to 0. So let's bring sine x to the other side. Cosine x is sine x, and let's get a single trigonometric function. We have both sine and cosine. If I divide both sides by what? Cosine x. Let's say to get tangent, I'll have 1 equals tangent x, right? Now, I have a single trigonometric function. I have an angle. I don't know what the measure of this angle is. Let's find this angle by using inverse function. X is equal to tangent inverse of 1, which is going to be 45 degree, pi over 4, right? So we got an angle. This is our reference angle. This is our reference angle. So this is not our original angle, this is our reference angle. So what are our original angles? First of all, we should remember in which quadrants tangent is positive. Remember the positive quadrants. Tangent is positive in the first and in the third quadrant. In the first quadrant, original angle is same as the reference angle. In the third quadrant, it is pi plus the reference angle. So pi plus pi over 4, 4 times pi, 4 pi plus pi, 5 pi over 4. So I got two original angles. Alright, so x equals pi over 4 and 5 pi over 4 are what makes the derivative of this function equal to 0, which means there are critical values. Okay, we answered the first part of the question. We got critical values. Now it's time to find increasing and decreasing intervals. So let's make a table of variations. Here it starts from 0 and at 2 pi. In between we have pi over 4 and 5 pi over 4. Derivative and original function. Alright, so we pick a number from one of the regions. So I generally pick a number bigger than 0. A little bit, a small number like 1. If you put 1 back in the derivative, what happens to the sign? 1 degree, for example. Cosine x minus sine x equals 1. When you put 1 for x, let's say cosine 1 minus sine 1. Type this in the calculator. See what happens. If you get the negative result, you put negative. If you get a positive result, you put positive. It gets a positive result. So for these kind of trigonometric functions, since there is no double root or stuff, then you start with a sign on one of the sides and change the sign in each region. Okay, this is the easiest way. I have no fear of having a double root or stuff, so I can try a region and change the sign for other regions. So I got positive in the first region, so other regions will be changed accordingly. Okay, plus means function is increasing, minus means decreasing, plus increasing. So now I will write the intervals easily. So increasing interval from 0 to pi over 4 union 5 pi over 4 to 2 pi. What about decreasing interval? There's only one, pi over 4 to 5 pi over. Okay, what else is left? On local extrema also we need to talk. So when function is increasing at first and then decreasing, there is local maximum. So at pi over 4, decreasing at first and then increasing, there is local minimum at 5 pi over 4. If we are asked to find the point, we are going to substitute these two values in the original function and find their y values too. Okay, this is how you solve trigonometric functions involving trigonometric functions. Questions involving trigonometric functions. The second question, exercise 23. Here we get tangent because we had sine and cosine both. Here we will have only one trigonometric function, so we won't get tangent. So let's start and see what happens. Derivative of this function is equal to positive 1 over 2. Derivative of cosine is negative sine x equals 0. Bring sine x to the other side. Sine x is half. To find the angle, let's use inverse function. Sine inverse function of 1 over 2, 30 degree. 30 degree means pi over 6 by radian. Since in Wazari they never use degrees in options, multiple choice questions, it's better to get used to converting degrees to radians. This is what we are going to see in options. So pi over 6 is the reference angle, right? So what are the original angles then? So look at the sign of sine. Sine x is 1 over 2, which is positive. In which region sine is positive? Sine is in the first region positive. And in the second region positive. In the first region, Pi over 6 is the original angle, which is same as the reference angle. In the second region, it's the second quadrant, it's pi minus the reference angle, which is 6 minus 1, 5 pi over 6. So x equals pi over 6 and 5 pi over 6 are critical values. Now it's time to make the table by using those two. From 0 to 2 pi, in between pi over 6 and 5 pi over 6, f prime and f. So let's determine the signs for each region. From the first region, let's pick a number, a value like 1. Let's put 1 back in the derivative. 1 over 2 minus sine 1. Is this a positive number or negative? Use your calculator. So you'll get a positive result. If the first region is positive, second one is negative, third one is positive. So here are the signs. So let's write the increasing, decreasing intervals. Increasing intervals from 0 to pi over 2, pi over 6, sorry. Union 5 pi over 6 to 2 pi. Decreasing interval, there is only one between pi over 6 and 5 pi over 6. Okay, one more thing. We are finding the local extrema. When the function is increasing at first and decreasing, there is local max at pi over 6. Decreasing at first and increasing, there is local minimum at 5 pi over 6. See? So we solve questions in the same way. First, we take derivative, find the reference angle, find the original angles, then make a sign chart and determine increasing, decreasing intervals, local extrema. All right. Okay, let's try one more question involving trigonometry. We will do some different, we will follow some different steps here. Okay, derivative here is f prime of x equals 2 sine x cosine x equals to 0. Remember the trigonometric identity. 2 sine x cosine x gives you sine 2x. So it's better to use sine 2x because I have two different trigonometric functions here. Here only one. So sine 2x is equal to 0. So in the previous two questions, we had another number. So by using the inverse function, we got the angle. Here, since the sine, if the cosine were equal to 0, sine or cosine equals 0, we have to use this way. Whenever the sine function is equal to 0, the angle is equal to k pi, if you remember. So 2x is equal to k pi, then divide both sides by 2, x is k pi over 2. This is our x. So these are our critical values. So this is the general form of finding the critical value, but to find specific critical values, we have to look at the given interval. This interval is important. So our critical values will fall in this interval. So how do you find the suitable x values that suits in this interval, that fits in this interval? Let's try some values. Let's try some numbers. What numbers? We know that n is an integer, so k. K is an integer value, so we give some integer values. Let's say if k is equal to, we have a negative value here. Let's start with -1, for example. What will your x be? If k is negative, it's negative pi over 2. Is negative pi over 2 in this interval? It's at the boundary, but it's not considered to be in this interval, so this is false. What if I try 0? What will x be? x will be 0. So 0 false in this interval, true. What if my k is positive, like 1? X will be pi over 2. Pi over 2 is on the boundary, so it's not element of this interval. There's only one value, x equals 0. So only x equals 0 is critical value. So for the results that we have k and whatever in it, we try some integer values to figure out the exact specific x values, so that the x values should fall in between the two values. It should be between in the given interval. So this is the only critical value. So make a table by using only this 0 between what, 2, negative pi over 2 to pi over 2 f prime f. Okay, let's pick a value. I prefer to pick the value from the positive side. When you put 1, for example, sine 2 times 1. Is that a positive result? Yes, it is. This region is positive, this one is negative, decreasing, increasing. So, increasing interval is 0 to pi over 2, while decreasing interval is negative pi over 2 to 0. Since the function is decreasing at first and then increasing, there is local minimum at 0. Okay. I think that's enough for trigonometric functions. Let's continue with a different type of function which involves natural logarithm, ln x over x. Let's take the derivative, which gives me derivative of top 1 over x times bottom minus top times derivative of bottom over bottom squared, which is equal to 1 minus ln x over x squared. So we have two cases. Since that's rational, let's consider both. Derivative being equal to 0, then top is equal to 0, then ln x is 1, then you exponentiate both sides by using the base of logarithm, which is e to the ln goes, so x is equal to e. This is a critical value because it makes the function defined. F of e is defined, so it is our critical value. What about the second situation? The second situation is function being undefined, the derivative being undefined. In order for derivative to be undefined, denominator should be 0. F prime is undefined, then denominator is equal to 0, then x is equal to 0. Is function defined at 0? F of 0, there is ln 0 over 0. No, it's not. It's undefined, so it's not critical value. Okay, we got two values. Remember, whether it's critical or not, to make a table, we are going to apply every number that we found from the derivative. We got 0, we got e, and what is the biggest value on the other side of e? It goes to positive infinity. Can we go to the negative infinity too? Can we go to the negative infinity too? Here we have to be careful because when we think about the domain of natural logarithm function, we know that the domain starts with 0. So we have to take the values bigger than 0 only. So the values less than 0 makes the original function undefined. So we don't have this region. So our graph starts with 0. It It's not from negative infinity to positive infinity. It starts from 0. This is where the domain of ln starts. Okay. So in this interval, let's pick a number. Okay, let's pick a number bigger than 0, like 1. Put it back in the derivative. 1 minus ln 1 over 1 squared. Is that a positive value? Yes, when you use your calculator, you'll see it's positive. This region is positive, this is negative, increasing, decreasing. So let's say increasing interval is from 0 to e, while decreasing interval is e to positive infinity. And I also see a local extrema. When the function is increasing at first and then decreasing, it yields a local maximum at e. All right. This is a nice question. Okay, let's take a look at this ministry exam question, the test question. It gave us this function. This is always what in its domain? Is it always increasing? Is it always decreasing? Is it always concave? Is it always convex? What is it? So for those kind of questions, if the function is simple, if I know the graph of the function, I immediately draw the graph to save time. Otherwise, I have to take derivative of this and see. I make the table and see it's increasing or decreasing or concave or convex. To do the concave and convex, we have to do the second derivative and stuff. It takes time, so I prefer graphing. Inverse functions graph, the parent function is this. This how it looks, 1 over x, but there is minus in front, so there will be reflection. So reflect your graph, plus there is translation, 2 units to where? It's plus 2 units to the left, and minus means reflection. So reflect your graph and move 2 units to the left. The vertical asymptote will pass through -2 then, and reflect on your graph. It's gonna be something like that, right? Okay, this is our new graph, 1 over -1 over x plus 2. So in this graph, what do you see? Do you see concave, always convex, always increasing, always decreasing? So this part of the graph is increasing from left to right. This part is also increasing from left to right. So it's always increasing then. All right, so option A is true. If you cannot think of graphing, you should take derivative, make a table, and see what happens. Okay. Example 15, which of the following function is satisfying the given conditions? So if you remember this question, we skipped in chapter 3. It is in chapter 3, section 1, exercise 30. So this question is in chapter 3, section 1 in exercise 30, and the same question came in Wazari. F of 0 is given as 4, f prime of 0 is 0, and the information is given. So which function suits this given information? Okay, let's figure it out. Let's try options one by one. F of 0 is supposed to be 4. When you substitute 0 for x, it should be 4. So it is true, 0, 4, true, 0, 4, true, 0, 4, true. So every option is true for the first condition. For the second condition, let's take the derivative of option A, for example. F prime of x equals 2x. When you substitute 0 for x, it's going to be 0. The second condition is also true for the first option. So let's go option by option. Let me finish the option A first. The second set of information, f prime is positive when x is positive, f prime is negative when x is negative. So let's make a table. It says When x is positive, f prime is positive. When x is negative, f prime is negative. So you have this function, decreasing at first and then increasing. Is it true for option A? Okay, when you pick a number more than 0 in the derivative, like 1, substitute back, it's positive. So it matches, the sign matches with the derivative. And the function is decreasing at first and then increasing. It's quadratic, it's parabola, decreasing at first and then increasing. It's also true. So option A is true. I don't need to try the other options. Okay, what did I do? I inserted 0 for x in the function. I got 4 as a result, true. I took the derivative, giving 0 to x in the derivative gives me 0. It's also true. I make a table by using those two given information. The table also matches with the derivative, because when I pick a number more than 0 and put it in the derivative, I got a positive result and negative on the other side. And function is supposed to be decreasing at first and then increasing. Yes, it is, because it's quadratic, it's decreasing and increasing. So every given information is true for option A. Okay, you can do the same for the other options and see what happens. Okay. Another example question, ministry question, a new one, 2023 first attempt. Can I make a graph here? If I make a graph, it's pretty easy, but I'm afraid I cannot. If I had only x plus 1 under radical, I would do that, but there is x also here. So let's take a derivative then. F prime of x equals 1 minus derivative of inside 1 over, you have 4 in front, let's write 4 to square root of the same function. Simplify. So 1 minus 2 over square root x plus 1. So let's check the first since that's rational, I will use both of the cases, derivative being 0, derivative being undefined. So if f prime is 0, then 1 minus 2 over square root x plus 1 is equal to 0. Then 1 is equal to 2 over square root x plus 1. Then cross multiply. Square root x plus 1 is 2. Then take square of both sides. X plus 1 is 4. Then x is equal to 3. I got something. So when I put this back, is it defined? F of 3. Put this in the original function. Yes, it is. No problem. So this is our critical value. So we got the critical value from the first case. What about the second case? Second case, f prime being undefined. In order for f prime to be undefined, then derivative should be 0. At the denominator should be 0 in this result. In the denominator, I see square root x plus 1. If this is equal to 0, then x should be negative 1. Is negative 1 true? When I put negative 1 back in the original function, it causes no problem. It's defined. So negative 1 is also critical value. So I got critical values. I'll make a table. I'm running out of space. Let me use this part. Negative 1 and 3. It goes to positive infinity, but does it go to negative infinity too? I'm not sure, because when I pick a number less than negative 1, like negative 2, it makes the function undefined. The stuff on the radical must be positive, but when I pick a number less than negative 1, it's going to be negative, so it will not be defined. So this region is undefined. Our table should start with negative 1. So let's pick a number. bigger than negative 1, like 0 for example. When you put 0 back, what happens in the derivative? 1 minus 2 over 0. Okay, 1 plus 1, or 0 plus 1. Okay, here I have 1 minus 2, which is minus, negative in this region, so positive in the other region, decreasing at first and then increasing. What we are looking for in the question is decreasing interval, which is between negative 1 and 3. So we solved every type of question involving first derivative test.